Okay, so this is number 6 from the second part of your review. And what it says is if f of x, you'll see f of x is in the denominator of this rational expression. If f of x is a polynomial function, polynomial functions you'll recall are things like just any function with many terms in it is the definition of a polynomial function. Like technically a quadratic would be a polynomial function, but it may very well be referencing something like this. X plus 1, something like that, right? Just many terms. The point that they're trying to make here is that it has many terms with the use of the words polynomial function. Okay, so does it always have a horizontal asymptote? And if yes, explain why, and if no, provide a counterexample. So I'll maybe just come up with a couple different examples here. The short answer is, if I were to write something like this function, right? If I were just able to write like, we'll call it g of x because they used f of x as the function in the denominator, but we'll say 1 over, let's say even something like x squared plus x plus 1. That, in that instance, you have to recall, because we're talking about horizontal asymptotes, you had 3 conditions for horizontal asymptotes, right? So horizontal asymptotes exist in 2 instances. One, where the degree in the numerator is less than the degree in the denominator. We'll move this over so I can summarize all this. Okay, we can also have a horizontal asymptote in the event where degree in the numerator is equal to the degree in the denominator. Okay, but those are your 2 conditions. We had a third instance that was revolving around horizontal asymptotes, and it was when the degree of the numerator was greater than the degree of the denominator, in which case you could long divide, right, in order to find what we called an oblique asymptote. Okay, so oblique asymptotes occurred in this third instance. Okay, and so in the instance in number 6, and what they're making reference to is, yes, there is going to have a horizontal asymptote in this particular instance because it's 1 over. So yes, here, if g of x happened to be, like, let's say they had another polynomial that was like, let's say h of x over f of x, and we had something like x squared plus x plus 1 divided by x squared minus x plus 5. That would have a horizontal asymptote where you have the degree in the numerator is 2 and the degree in the denominator is 2, right? So that would have a horizontal asymptote at a ratio of leading coefficients. Right, and so it would have a ratio, it would be y equals 1 there. Okay, up here it would be at y equals 0. Okay, and the last instance we'll say z of x or something is equal to h of x by f of x, where h of x was, say, something like x squared plus 3x plus 4 divided by x plus 1 or something. That would have an oblique asymptote because the degree of the numerator is x squared and the degree of the denominator is 1. Okay, so it lends itself to be long divided in and then you would get an equation for an oblique asymptote, okay? So that's pretty much that question, right? They're always gonna, in that particular specific example that they have provided in number 6, it is gonna be 0 all the time, right? But you could also have horizontal asymptotes that are not 0, and then in the event that the degree of the numerator is larger than the denominator, then you would have an oblique asymptote.